Discovering hydrogen, the element of life and energy. Hydrogen, with the symbol H and atomic number 1, is the simplest and most abundant element in the universe. Its name is derived from the Greek words hydro, meaning water, and genes, meaning creator, as it forms water when combined with oxygen. Discovered in 1766 by English scientist Henry Cavendish, hydrogen was initially referred to as inflammable air due to its combustible nature. It has an atomic mass of approximately 1.08 and is placed in period 1 of the periodic table, although it doesn't belong to any specific group due to its unique properties. Hydrogen exists as a colorless, odorless gas under standard conditions, making it the lightest element in the periodic table. On Earth, hydrogen is rarely found in its pure state due to its high reactivity. Instead, it exists in compounds like water, H2O, and hydrocarbons such as methane, CH4. It is abundant in the oceans and atmosphere, but constitutes only about 0.15% of the Earth's crust. Biologically, hydrogen is essential, forming a key component of water, which makes up the majority of the human body, and it is also found in vital biomolecules such as proteins and DNA. Although pure hydrogen gas is non-toxic, it can pose a suffocation hazard in confined spaces by displacing oxygen. Hydrogen has an incredibly low density of 0.00008988 grams per cubic centimeter, GCM3, at standard temperature and pressure, making it the lightest element in the periodic table. This unique property contributes to its widespread use in various scientific and industrial applications. At room temperature, hydrogen exists as a gas, but under extreme cooling, it transitions to a liquid state at 252.87 degrees Celsius, and further to a solid state at 259.16 degrees Celsius. In its pure form, hydrogen is a colorless, odorless, and tasteless gas consisting of diatomic molecules, H2. When solidified, it takes on a hexagonal crystal structure, a state that is rarely encountered outside highly controlled scientific environments. These physical properties, combined with its abundance and reactivity, make hydrogen a crucial element in understanding both fundamental chemistry and practical applications. Chemically, hydrogen is highly reactive and readily forms bonds with other elements. One of its most notable reactions is with oxygen to produce water, H2O, releasing substantial energy. Its reactivity also means it combines easily with carbon to form hydrocarbons, and it acts as a proton donor in acids or as a hydride when bonded with metals, demonstrating its versatile chemical behavior. Hydrogen has a wide range of applications. It is a clean energy carrier and serves as the fuel for hydrogen fuel cells, which produce electricity by reacting hydrogen with oxygen, emitting only water as a byproduct. It is also used in the production of ammonia for fertilizers, in refining processes in the petrochemical industry, and in the synthesis of methanol. Additionally, hydrogen plays a critical role in scientific research, metallurgy, and space exploration as rocket fuel. Its versatility and potential as a sustainable energy source make it a cornerstone of modern technology and a key element for future innovations. Please don't forget, click to subscribe button for latest news videos.